We're on page 5 in the book, chapter 1, section 1, and today we're going to be talking about points, lines, and planes, as those words are used in geometry. So the key concepts in this book are obviously pretty important. So we're going to define a point. Yes. No, I'm going to do that for you. And you're going to write it down. Okay. Thank you though. Point. That's a location. Has no shape or size. It's named by a capital letter. All right, so point A right here. Now, a line is made up of points. Has no thickness or width. There is exactly one line through any 2 points. It's named by a lowercase script letter or any 2 points on the line. So here we go, a line. When you're drawing a line, it is important that you put arrows on both ends because lines don't have endpoints. They go on infinitely in both directions. Here's a script lowercase letter. We could call this line M right now. If we put some points on this line, like point P and point Q, well, now we could call this line PQ or line QP. So here's some names for this line. All right, line M. Little symbol for line, which is just a small line, and then line PQ. And we could also call it line QP. Any 2 points on the line. You could use any 2 points on the line to name a line. If there's 3 points on there, if there's 4 points on there, you could use any of those points. If we added a point right here, called it point A, we could now name this line AQ. We could also name it line AP. All right. Any 2 points on the line or lowercase script letter that is usually located right near one of the arrows at the end of the line drawing. All right, and then next we have a plane. Is a flat surface. Top of your desk is an example of a plane. A flat surface made up of points that extends infinitely in all directions. There's exactly one plane through any 3 points, not on the same line. Now, when you're drawing a plane, we start here with this quadrilateral looking shape, 4 sides. There's 2 ways to name a plane. Capital script letter. In this case, they're using K. You could also name a plane using 3 points. Not on the same line. So if I put 3 points in this plane, point D, point B, and point C. All 3 are not on the same line, are they? All right, so we can use those 3 points to name the plane, or we could use this capital letter K. So the symbol for plane is just a small shrunk down version of a plane. So we could call this plane K. And now we could use these three non-collinear points, or 3 points not in the same line. And we could use them in any order. So we could call it plane CBD. Call it plane BDC. Any combination of 3. Yes. Can't hear you. A plane can have more than 3 points, yes. A plane can have an infinite number of points. Just when you're naming the plane, you have to choose 3 points that are not on the same line, okay? If you use 3 points that are on the same line, then you could be talking about multiple planes, all right? So down on the bottom of page 5, there's a couple of terms that are extremely important. First one is collinear. Collinear means on the same line. Collinear means on the same line. If 5 points are collinear, those 5 points are all on the same line. And if collinear means on the same line, then non-collinear means, there you go, not on the same line. So if you wanted a visual, here's a line, right? Line L. And if we put point A and point B, point C, point D, and point E, if all of those points are on line L, then A, B, C, D, and E are collinear. Now, if we were to draw another line, line M, and here we'll put point P on it, but then N is not on that line. We've got point Q that's on the line, point A not on the line, and point R. In this case, points P, Q, and R are collinear, aren't they? P and Q are collinear. Q and R are collinear. Are points P, N, and Q collinear? No, because they're not on the same line, are they? What about Q, R, and A? Are they collinear? No, those are non-collinear points. Everybody all right with that? Collinear, non-collinear. The same works for coplanar. Points. In the same plane. Points that are in the same plane. If we draw a plane, call it plane M. If we put points A, B, C, in the plane, then points A, B, and C are coplanar. They lie in the same plane. They're all in plane M. And a partner to coplanar would be non-coplanar. And if coplanar means points in the same plane, what does non-coplanar mean? Very good. Points not in the same plane. All right, so A, B, and C are coplanar. But A, B, C, and D are not coplanar, are they? Points B and C are coplanar. But C and D are not coplanar. Okay? All right, so let's flip the page and look down at the bottom of page 6. Intersections of lines and planes. This is something that you want to star. This is important. Lines intersect at a point. Lines intersect at a point. We're on the bottom of page 6 right now. If you draw line L and intersect it with line M, they intersect right here, don't they? Right on this red dot. I'm calling it point A. Lines intersect at a point. Line L intersects line M at point A. Planes intersect at a line. Planes intersect at a line. Now, this is a little bit too hard for me to draw, but there's an example of plane A and plane B intersecting on the bottom of page 6. The blue plane B and the green plane A intersect at line R, don't they? And if you think of the front wall of the classroom where the projector is shining, that front wall is a plane. And the ceiling is a plane. And they intersect at that edge that goes all the way along the top, doesn't it? Don't they? And that forms a line, doesn't it? So the ceiling and the front wall intersect at a line. It's at the front of the ceiling and the top of the wall. And then the front wall and the floor intersect at a line, don't they? Okay. So planes intersect at a line and lines intersect at a point. Very important. All right, so then let's look at example 3 on the top of page 7. Draw geometric figures. Draw and label a figure for each relationship. So what they're doing there is they're giving you a description. Lines A, B, and C, D intersect at point E. For A is -2, 4, B is 0, -2, C is -3, 0, and D is 3, 3. On the coordinate plane, point F is coplanar with these points, but not collinear with A, B, C, or D. Graph each point and draw A, B, C, and D. So look, if you're asked to graph those points, then let's just sketch as neatly as you can. This is where that graph paper comes in handy, but if you don't have it, don't worry. Just as neatly as you can, a vertical line, and then a horizontal line through it. We've just created an XY axis. Graph and label, graph each point and draw A, B, and C, D. So point A is at -2, 4. So here's our -2. And then we go up 1, 2, 3, 4. So -2, 4 is point A. And then point B is at 0, -2. So 0 on the x-axis, -2 on the y-axis would be right here. So here's our point B. We're going to draw a point AB. So the best that you can. If you have a straight edge, go ahead and use it. If not, then just the best that you can. Try to get a line, as straight as possible line that goes through A and B. So there's your line AB. Point C is at -3, 0. So here's -3, 0. That's right on the x-axis. Point C. And then point D is at 3, 3. So we go 3 on the x, 3 on the y. We now have a point D. And the best that you can, we're going to draw a line from C through D. So we've got line AB that's going up and to the left. We've got line CD that's going up and to the right. Label the intersection as point E. So where those two lines intersect, right here at this red point, and we're going to call it E. Everybody okay with that? Getting a couple of lines on the coordinate plane and then determining the point of intersection and labeling that point. Any questions on anything we've talked about today? Okay, then let's flip the page. And your practice problems for today are going to be on page 8. Going to start on page 8 And I want you guys to do 13 through 31. Page 8, problems 13 through 31.